This is a project SWE Quest, Swedish question generation for assessing reading comprehension. This is Johan Boye speaking. I'm a researcher at KTH, and I'm doing this project together with Maria Rydell at Stockholm University. The goal of this project is to create a system that can generate reading comprehension questions from a given text. So here's a teacher. He has selected a text that he wants his students to read, and then he wants to check whether or not his students have understood what they have read. So he presses the button, and the system generates a number of multiple choice questions in this form. So here's the text is about Stockholm, and here's a question: what makes Stockholm one of the world's cleanest cities? And here are a number of alternatives. So one of these is the correct alternatives, and the other are distractors, which means that they are incorrect but still plausible alternatives. So this is what the project is about then. We intend to implement a demo system that can generate this kind of reading comprehension questions in the form of multiple choice questions, or MCQs. And although the example I just showed you was in English, we intend to do this for Swedish texts. And we're going to use the latest advances in artificial intelligence neural networks to do so. And we also want to evaluate the system with the help of teachers in SFI, which is Swedish for immigrants. So we want to generate questions with the help of the system, and the teacher's gonna decide whether or not these questions are good and useful.
There are a number of pedagogical challenges associated with this project. Assessing reading is considered difficult. Reading is to a large extent an invisible process, and it's also a very complex process. Multiple choice questions is a commonly used test format, and it's associated with both advantages and disadvantages. So some advantages are that it's a format that is recognized by most students. It doesn't require the student to express the answer herself, which is important because as a teacher, you would sometimes want to discern the student's reading comprehension and not let the assessment be influenced by the student's writing or speaking abilities. And this is important because most learners comprehend more than they can express. And it's also a format that is suitable for automated scoring. However, there are also some disadvantages associated with multiple choice questions. It is more difficult to target complex reading processes, such as when the student should interpret or reflect upon the reading. There are also a number of challenges associated with the difficulty of discerning the student's reading comprehension and nothing else. The student can always guess, and you would want to avoid a situation where one alternative is obviously incorrect. And depending on the topic of a given text, the student's prior knowledge can influence how they answer, and you would want to avoid a situation where the student can answer the question without reading the text. For a human test constructor, it is time-consuming to construct MCQs of good quality. It takes time to find or construct appropriate texts. A particular challenge is associated with the construction of plausible but still incorrect distractors. So a common problem can be that the distractors are too close to the correct answer. It is also a challenge to construct MCQs that target different reading processes, such as finding information, making inferences, understanding the gist of a text. What we see and find interesting is that an automated system would face the same kind of challenges that a human constructor does. One aim with the project is to automatically generate MCQs that target different aspects of reading comprehension. And we will now show you two examples. So the example you see here is a descriptive text about millionaires and billionaires in the world. And it requires students to find information that is explicitly stated in the text. And as you can see, all alternatives are mentioned in the text, which makes them plausible alternatives. The next example is a little bit more difficult than the previous one, since the correct answer is not explicitly stated in the text. In this example, the question requires the students to make an inference about Sylvia's prior knowledge of Mick's profession. Although the answer is not explicitly stated in the text provides several clues, as you see highlighted here in yellow, to which sentence is most likely to be true.
So how can we go about constructing a program that can automatically generate such reading comprehension questions from texts? So now you've seen two examples. So in the first example, the text about billionaires, the relationship between the question and the text was quite straightforward, and the correct answer appeared in the text verbatim. And in the second example, the relationship between the question and the text was less straightforward. So I think we can conclude that there's just an enormous amount of ways that reading comprehension question can be related to a text. And there's just no way we can manually specify all these ways. It wouldn't be practically achievable. So instead we're going to use a data-driven approach. This means that we're going to have a system which we're going to show a lot of examples of text with associated multiple choice questions. And the system is going to learn from those examples. So if the learning is successful, the system will then be able to generate questions from text it has never seen before. So in order to do this, we have collected a data set with texts and associated multiple choice questions, and we have 3,000 of those, and we are continuing to collect these texts. And if you know a little bit about machine learning, 3,000 examples might not sound much, but we are leveraging the latest advances in artificial intelligence here, and we're going to use a large neural language model. This is a large so-called neural network, which has been trained to know a lot about the Swedish language. And we're going to use that and fine-tune it in order to solve our particular problem here of generating questions. And in fact, we are constructing several models or several networks. One which can construct a question from the text and a correct answer, and another one which can construct the question and distractors from the text and correct answers, and so on. So in order to collect our data set, we have employed students who've been working with this kind of interface. So to the left, they have the text. This is a text about shopping on the internet. And then the student can write the question and mark the correct answer in the text, and also mark the distractors, these other incorrect alternatives in the text, if they are present in the text. And once we have trained our neural network to generate questions, here's how we use it. So we input a text and the correct answer, and the neural network will then generate the first word in the question, which is how in this case. And then we just register that we've seen how, and then we're going to input the first word of the question together with the text and the correct answer again, and the network generates the next word, many. We register many, and then we input how many to the network, and then the next word is generated, people, and so on. And this process goes on until the network generates a question mark, which is the end of the question. And then it can go on to generate the distractors as well. To sum up the contributions of the project, we believe that we will push the state of the art in natural language processing, which is the subfield of artificial intelligence that deals with generating and understanding human language. And in particular, we will generate entire multiple choice questions with not just the question, but also the distractors, as we have shown before. And we will do so in Swedish, so most of the research otherwise in this area is made in English. And we will also put a lot of attention into evaluation of the system using teachers that are teaching in the SFI program. And as an end product, we will release open source software and a demo system.
So why is this important? Well, we live in a text-based society with high demands of literacy in the society at large and in the labor market in particular. And just to provide you some background, 20% of the Swedish population is born outside Sweden. 1 million people immigrated to Sweden between the years 2013 and 2020. This has led to a significant rise of the number of students in SFI. The students in SFI constitute a very heterogeneous student group when it comes to their linguistic, cultural, and educational background. And SFI has been criticized for not sufficiently adapting the teaching to the students' individual levels and needs. So we believe that the methods developed in this project could provide a flexible tool for teachers to assess the students' reading comprehension and to adapt the content to the students' needs.
Please don't hesitate to get in touch with us if you want to know more about the project, and you can find all contact details here on this final slide.